All right. Good morning. Hope you had a nice weekend. Okay, so I've now assigned the odds and the evens for that last lesson. And I think I said that the exam would only be on that one lesson. What was it, 7.5? Hold on, let me look. Yeah, 7.5, but it's the next exam will be 7.4.7.5. So 7.4.7.5. Remember 7.4 was you're solving by the methods substitution and then addition where you stack them. So I want to take questions that you might have on any of that. Then I'm teaching a new lesson today in chapter 10. So we're going into sequence and series. And then in 10.2, we're doing arithmetic sequence and series. And then in 10.3, we're doing geometric sequence and series. So some new stuff. All right, anybody want me to work any problems at all in 7.5 or even 7.4? Anybody have any questions? I'll be asking if you have questions until we exam. I do not have the exam scheduled yet, but just depending on how many questions and that we have. If we don't have any questions, it'll be sooner than later. A lot of questions, then I'm going to try to figure out when I should schedule the exam, 7.4, 7.5. Okay, anybody want me to work a problem or anybody have any questions? All right, well, this past
I
weekend,
have a question.
Go ahead.
Let me just get the specific problem. Give me a second.
Weekend, I did put, see, it takes me a while to in Zangle because I record them in my grade book and then I transfer them to Zangle. So it takes a while, especially with the exams, because I have to see if you turn in your scratch paper. I have to look at the scratch paper. So it takes some time. So if you're somebody, we're close to May and the end of May, school is out. Seniors are actually taking finals the end of May. If you have a grade that's in the 50s, or you really want to pass this class, you should meet to see what the options are. So the grade that's in the grade book is the most current grade right now. And so if you're close to passing and you're not quite there, you should set up a meeting with me. All right, Bernie, did you find the problem?
Yeah, I was going to ask you about question 19 on 7.5.
7.5.19?
Yeah.
All right, 7.5, the problems are on page 863, and you're asking about 19, is that correct?
Yes.
So number 19 is y is less than x squared minus 1. So let's read the directions. It says graph each inequality. So this is not a system. The reason why it's not a system is because there's not two or more inequalities. So this is just a single inequality, which means we'll have to do the 3 steps. We're going to have to figure out how to graph it, number 1. Number 2, we're going to have to find out if the boundary is dotted or solid. And number 3, we're going to test a point to see where we shade. All right, so the first thing that I was telling you is that you have to figure out what you have. Because if you have a line and you graph a parabola, you're going to be wrong. If you have a circle and you graph a line, you're going to be wrong. So you want to know what you have. So what is this when you have one square?
A quadratic?
Right. It's a quadratic. It's a parabola. And if you remember back in the prerequisite section, I showed you how to do transformations from a parent. So the parent is the most simplistic graph. And we put a 0 in, 0 squared is 0. when you put a -1 in, -1 quantity squared is 1. And when you put a 1 in, 1 squared is 1. So those are the parent points. And so what we did is we studied A, B, H, and K. And we want to know, what is this? Is this A, B, H, or K? What is this telling you to do with the parent? Go ahead, I'm listening. Is this A, B, H, or K? And what is it telling you to do the parent?
Is it K?
It is K, and it's down 1. If it was H, it'd be in parentheses, and it's not. So if it was, it would look like this if it was H, but it's not H. It's K, it's outside the square. So outside the square is going to be A or K, inside would be B or H. All right, so what you do is you take these parent points and down would be the Y. So you leave the X alone, and down 1 would be -1, down 1 would be 0, and down 1 would be 0, and you graph the points. And you know what a quadratic looks like. It looks like that. So we're going to graph 0, down 1. We're going to graph left 1, 0. And we're going to graph right 1, 0. And for those of you who are really good at that, you could have just taken the parent and shifted it down 1 without doing this. You should be able to look at it and just go shift the parent down 1. All right, so now the second step is decide about the boundary. So the boundary's dotted. Dotted means the solutions cannot be on the boundary. And then we test a point. So I like to test 0, 0. So I make a little mark there to show that it's, in this case, it's inside the parabola.
Wait, Miss Birch, why is it dotted again?
Because it's less than.
Okay.
So less than or greater than is dotted. Less than or equal to, greater than or equal to is solid. Right? Right? So 0 less than 0 squared minus 1 is 0 less than -1. So 0 is not less than -1. So don't shade it. So what does don't mean?
Shade the other side.
Shade the other side. So instead of shading inside the parabola, you're going to shade outside the parabola. And that means the solutions inside, those ordered pairs are not solutions. And the ordered pairs outside are solutions. All right, any questions about this? Questions? So I'm just letting you know that on the last exam, there were 2 people that got 0s. And the reason why they got 0s is because they didn't show their work. So I'm just letting you know that if you're going to use a calculator and not show your work, if you're just going to write down answers because you use the program that gets the answers for you that exists out there, you're going to get a 0. So you have to show the work. It's the only way to justify that you're actually doing the problem online. Because remotely, it's really easy to have a bunch of different resources to get the answers. And so I'm being really strict about this. You must turn in your scratch paper and you must show the work to prove that you're actually doing it. If you don't do that, I'm showing 0 tolerance because I've been asking you to do that since August. And so I'm really not giving anyone a break at all. So if you don't turn in your scratch paper, you're getting a 0 on the exam. If you're not showing work, on the scratch paper and showing correct work. The two people that I'm talking about were just showing a bunch of garbage, and I'm not, don't insult me, because I am looking at it. Don't write a bunch of garbage and expect me to give you credit, because I will not. All right, other questions? All right, last call. Anyone want me to work any problems?
Could we do like 27 maybe? Or...
27 is a system. It's 3x plus 6y is less than or equal to 6. 2x plus y is less than or equal to 8. And so I'm actually on the first, I'm going to divide everything by 3 because I'm going to simplify it down. So if I divide everything by 3, I get x. Divide by 3 would be 2y. Divide by 3 would be 2. And on that one, I'm just going to leave it alone. Notice that I put equal signs because we're using equal signs to graph. Okay, on this one, I'm not going to solve for y. On this one, I will solve for y. So on this one, I'm using the x and y intercept method. So you set x equal to 0, and you get 2y is equal to 2, divide by 2, divide by 2. So you found the y-intercept 0, 1. Set y equal to 0. So you get x is equal to 2. So you just found the x-intercept, write 2, 0. Graph them. So this is 0 up 1. This is right 2, 0. Connect the points. The second step is to see if the line is dotted or solid, and it is solid because it has an equal in it. And we're going to test a point. I'm going to test 0, 0. This time 0, 0 is on the bottom. So put it in here, 3 times 0 plus 6 times 0. Is that less than or equal to 6? Is 0 less than or equal to 6? That's true, so shade it. The second graph, we're going to graph on the same graph. We're superimposing it on the other graph, but it's a totally different graph. In this case, it is easy to solve for y, so I'm going to subtract 2x, and I'm going to use slope-intercept form. So basically what I'm doing is I'm using the most efficient method on each one to get this done as quickly as possible. So the slope is down to right 1, down to right 1, or up to left 1, up to left 1, and the y-intercept is 0, up 8. So we could go 0, up 8. And I'm out of room, so I do not want to go up to left 1. I'm going to go down to right 1, down to right 1, down to right 1, down to right 1, down to right 1. Draw the graph. Okay, now we decide if the boundary is dotted or solid. It is solid. And once again, I'm going to test 0, 0, which is on the left side of the graph. I'm going to warn you about something. You don't want to just guess and say, oh, less than means below. Because if that slope is tilted just enough, you're going to shade in the wrong place. So you want to test a point. If you don't, you're in danger of shading in the wrong area. This would be 2 times 0 plus 0. Is that less than or equal to 8? Is 0 less than or equal to 8? That's true. So shade it. All right, now your solutions are only where you see black and green. So where do you see black and green? Go ahead, I'm listening. Where do you see black and green? You see it in here, right?
Yes.
So what you're going to do is it's not over here. So it's going to be this boundary solid. It's going to be this black boundary solid. And you're going to shade where you see only black and green, not where you see green or black, but black and green. Just going to check my book real quick. Make sure it's right, 7.5. And this is problem number 27. So this is correct. All right, any questions about any part of this problem?
So, Ms. Birch, I'm not trying to sound silly or anything, but so our solution is the shading. So it's obviously our solutions are like whether it's true or not, like testing.
Yeah.
Okay.
Well, it not only does it have to be true,
Mhm.
it has to be where you see black and green. So you see these green solutions up here?
Yeah.
They only work for the second one. These black solutions, which you can't really see, these black solutions over here, they only work for the first one.
Mhm.
And so where I colored in red, you can see the colors, is where the ordered pairs work in both. So if you pick like 0 down 1, it's going to work in both. If you pick right 1 down 10, it's going to work in both. If you pick 0 up 4, it's only going to work in the second one. If you pick like right 10 down 3, it's only good, or not 3, right 3 down like 7 or something, it's only going to work in the top one. So the red ones, the red ordered pairs, like left 1 down 2, left 1 down 10, left 3 down 100, all those ordered pairs work in both. And if you don't believe me, try them. You know, pick an ordered pair in here and try it in both, and it'll work in both. In other words, it'll make it the statements true. All right, any other questions about this? Okay, can I erase this?
Yeah. Ms. Birch, I just have one more problem, like, if that's okay.
I may not work it, but this is taking, you know, I've given a lot of examples in the notes, and I expect you to look at your notes. So I've given you everything that you need in your notes. So we'll see how long it is for me to work. Which one are you going to ask me about?
I was going to ask you about 33.
33? Okay, it's exactly like the problem I just did. And how about this? Why don't you try it and I'll work it tomorrow or Wednesday? I'll work it Wednesday if you ask me.
Okay.
All right, are there any other like general questions about stuff? Okay, when I ask for questions, I'm not necessarily asking to work problems. I'm asking for like specifics, like how do you do slope-intercept form? How do you graph those ordered pairs you come up with in the other method? You know, so I'm asking for like questions, not necessarily problems. All right. So we're going to start 10-1, and I actually made a note sheet for you, but you should really when you go to college, I don't care where you go, if you go to Valley, RCC, or somewhere else, you're going to have to take a math class, okay? In your math class, I recommend that you make sheets of formulas. So I made this for you, but you should get in the habit of making a formula sheet yourself. It's a way to see with your eyes in one shot the formulas you're going to be tested on. So these are the formulas you're going to be tested on in this new section, this new chapter. So you want to get in the habit of doing this. Now I put this in your your lesson that I posted. So if you're able to print this out or have it in front of you, that's what I recommend, is that for this new chapter 10, if you can print this out and have it in front of you, that would be good. What normally happens is I have you memorize these, but since we're doing this distance learning, it's difficult to have you memorize stuff because I can't tell if you're using the note sheet or not. So you guys have an advantage. If we were in school, you'd have to memorize these, and you wouldn't be able to use a note sheet on the exam. All right, so in 10.1, there's 4 objectives. And I'll just tell you what we're going to do. We're going to look at just basically the foundation of arithmetic and geometric sequence and series. So basically, I'm giving you vocabulary and just basics today. All right. So the first vocabulary word, well, first of all, let me write this down. So 10 is going to be sequences, and something called summation notation. All right, so the first definition is the word sequence. And a sequence is just an ordered set of numbers. For example, 1, 2, 3, 4, going forever. Now, what I want you to notice in here is you notice the commas are separating the elements, and this ... means it goes forever. Don't use 4 dots, don't use 10 dots, don't use 2 dots. This is called an ellipse, and you always use 3 dots. This is called, this is called an infinite sequence. If you have 1, 2, 3, 4, and it stops, that's called a finite sequence. So a sequence is an ordered set of numbers, and I just showed you what an infinite sequence looks like and a finite sequence. So the first objective is they're going to ask you to find particular terms. So you've already heard me say that. Well, these things are called terms. They're also called elements, but mainly terms of a sequence. From the general term. So a lot of you are going to do really, really well in this chapter. Some of you are going to find this to be really easy, and you could score high on this exam when we take it. So the first set of directions say, write the first 4 terms of the sequence. Whose nth term is given. All right, you guys. So what they're doing is they're asking you to come up with the first 4 terms, and they're saying of the sequence whose nth term. The nth term is the rule. So in the example, they're going to say a sub n is equal to 3n plus 4. So let me just explain what this means. If you put a 1 in for n, you're looking for the first term. If you put a 0 in for n, you're looking for the 0 term. If you put 5 in for n, you're looking for the 5th term. So let me just make a note here that the nth term.
Ms. Birch, can you move the camera? Like to the right. Thank you.
The nth term is the rule. So this is really easy, you guys. If you want to find the first term, you say a sub 1 is equal to, wherever you see an n, you put a 1. So 3 plus 4 is 7. So that would be the first term. Now we go and find the second term. So this is the rule. So this would be 3 times 2 plus 4 would be 6 plus 4, which is 10. So now we're going to find the third term. So we put a 3 in for n plus 4 would be 9 plus 4, which is 13. And then we find the fourth term would be 3 times 4 plus 4 is 12 plus 4, or 16. Now, you are not going to leave it like that. You are going to write the sequence. So they're asking you to find the terms of the sequence. So make sure that you write the sequence. So you would write 7, 10, 13, 16, and that's your answer. And you would do this work to show that you know how to do it. Now, there's rules. This is just one rule. So let's do a problem with another rule. So that's a pretty easy rule. This one says 3 times n plus 4. All right, anybody have a question about how to do that? Can you respond out loud then? I don't want to turn the chat on right now. I'm trying to do something.
Yeah, I understand it.
Okay.
Yeah, same.
Okay. So this rule is a little bit harder. It's a sub n is equal to, okay, look at, it's a -1 to the nth power over 3 to the n minus 1. Now, you do realize that if you have an n that's even, the top is going to be a positive 1. If you have an n that's odd, like 3, 5, 7, the top's going to be a -1. Because remember we talked about this? If you have a negative to an even power, like 2, 4, 6, or 8, this is going to be a positive 1. If you have a negative to an odd power, like 3, 5, 7, or 9, the top's going to be a -1, right? Right?
Right.
All right. So it's the same directions. They want us to find the first 4 terms. So here we go. So we're going to find the first term. It's called a sub 1. So wherever you see an n, you're going to put a 1. Wherever you see an n, you put a 1. So what's a -1 to 1, guys? Is it going to be a -1 or a positive 1?
A negative?
Right. And this is going to be 3 to the 1, which is 3. 3 minus 1 is 2. So there's your first answer. Then we find the second term, which would be -1 squared divided by 3 squared. Wherever you see an n, you put a 2. So here we go. What's a -1 quantity squared, guys?
+1?
+1. And wouldn't this be 9 minus 1?
Yeah.
Yes or no? So we don't have to write it down. You can write it down if you want, but 9 minus 1 is just 8, right? So there's some things we can do in our head now. So now we're going to do a sub 3. So this would be -1 cubed divided by 3 cubed minus 1. All right, so what's a -1 quantity cubed? Is it +1 or -1?
-1?
And what's 3 cubed? It's not 9, right? Because 3
27.
cubed means 3 times 3 times 3, which is what?
27?
Yeah, so what's 27 minus 1?
So it'd be 1/26.
Right. All right, now we go to a
Negative
sub
1.
4. So this would be -1 to the 4th divided by 3 to the 4th minus 1. So what's -1 quantity to the 4th?
+1.
Right. And what's 3 to the 4th? It's 3 times 3 times 3 times 3, which is what? What's 9 times 9?
81. It'd be 81. So it'd be 80.
81. So 81 minus 1 is 80. That's right. Okay, now you're not going to leave the answer like that. You're gonna show me that work to show me that you didn't get it off one of those programs that give you the answers. And you're gonna write the sequence in order. So a sub 1 would be -1/2. Do you, Bernie, can you mute yourself? A sub 2 would be 1/8. A sub 3 would be -1/26. And a sub 4 would be 1/80. Pretty easy, right?
Yup.
So you guys are going to get that right on the test, right?
Yes.
All right.
Yeah, for sure.
Okay, that's the first objective. The second objective almost made me fail out of my freshman year at UCR because I did not understand what recursion meant. And what happened is in my first computer science class, I had to write a program that was based on recursion. And I had no idea what it was. So at least you're going to know what it is. Because the second objective has to do with using recursive formulas. So if you're planning on going into gaming, if you're planning on writing software for games, if you plan on doing computer graphics, if you're doing anything with computers, you might need to know what recursion means. I had no idea what it meant, and here I had to write a program. I had to write some code with recursion. All right, so let me define it. What is a recursion formula? Okay, it defines the nth term of sequence as a function of the previous term. So what the heck does that mean? I don't know, let's read it again and see if we understand it. It defines the nth term of a sequence as a function of the previous term. Okay, I'm going to show you what this means. All right, so for example, they would say something like, find the first 4 terms of a sequence and look what they do on this. They give you the first term for some reason. So they say that a sub 1 is 5. So they're telling us that the first term is 5 for some reason. And then they give us the rule. It's 3 times a to the n minus 1 plus 2 for n being greater than or equal to 2. Now, what the heck is going on and what does all this stuff mean? All right, well, I'm going to show you. Don't write anything down yet. I'm going to write, like we did last time, I'm going to write down the rule. And I'm going to put in a 1. Well, look at this thing. We don't, so I put in a 1, but now I have a sub 0. We don't know what that is. So what's going on here? I mean, what do we do? Well, they actually gave us the first term. So they said that the first term is 5. And so it's like, okay, fine. If they want to give it to me, fine. Now I got to find a sub 2. So this would be 3 times a. N is your 2 minus 1 plus 2. Well, check this out. When you simplify this, isn't this 3 times a sub 1? So isn't this requiring the previous term? So do you know what that means? That means that if they don't give us a sub 1, we can't even do this problem. So they have to give us a sub 1 because when we go to do this, it's requiring the previous term. And that's what recursion is. So watch. This is going to be a sub 2 is equal to 3 times 5 plus 2. So a sub 2 is equal to 15 plus 2, which is 17. Well, it's like, okay, well, what's going to happen with a sub 3? I don't know. Let's use the rule. So this would be 3 times a sub 3 minus 1 plus 2. And so far I'm okay. And I get 3 times a sub 2. Well, isn't that requiring the second term? So you see what's going on here? The second term requires the first term. The third term requires the second term. And the fourth term is going to require the third term. That's what's going on. So what's a sub 2, guys? What's a sub 2?
17.
So what's 3 times 17? 51? Hello? It's 3 times 17.
Yeah.
So 51, 53. And now we have to find the fourth term. So a sub 4 is, follow the rule, 3 times a to the 4 minus 1 plus 2. So isn't that a sub 4 is equal to 3 times a sub 3? So see how it's requiring the third term? So what's the third term?
$53.
So what's 3 times 53? 159. So 159 plus 2 is what, 161? So if they give you a recursive problem, they have to give you the first term. If they do not give you the first term, you're not going to be able to do the problem, because the second term requires the first term, the third term requires the second term, and the fourth term requires the third term. That's recursion. So we got to write our answer. So they gave us the first term, that was 5, 17, 53, and 161. So that's our sequence. So notice that over here, look back at the problem. Not only are they giving us this, the first term, they're saying that our n has to start at 2. And that's exactly what we did. We started the n with 2. Now, are you guys okay with this, or do you need me to explain this further?
No, I'm all right.
Yeah, I understand it.
I'm not going to do another problem, so if you have a question, ask me about this. Okay, that was the second objective. All right. Let's move on to the third objective. And it's called factorial notation. So let me define a factorial. It looks like this.
Ms. Birch, can you move the camera, please, to the left? My bad.
And another fact is that 0 factorial is equal to 1. Now, this is really easy. If you have 3 factorial, all you're going to do is start at 3 and go multiply down to 1. If you have 5 factorial, you're going to start at 5 and multiply down to 1. If you have 10 factorial, you're going to start at 10 and multiply down to 1. So basically, this is just 3 times 2 times 1, which is 6. 5 factorial. You start at 5 and you multiply down to 1. 5 times 4 times 3 times 2 times 1. So that would be 20 times 6. And I think 20 times 6 is 120, if I'm not mistaken. You want to do another one? No?
Ms. Birch.
Yeah.
So what's the pattern here? Like, okay, obviously we did, the third, like 3 and then exclamation point. Or what is that supposed to be called? The exclamation point?
Factorial.
The factor. Okay, so 3 factorial. So we would pick the last like 2. Oh, okay, I get it now. So it has to match. Okay. All right, for sure. Never mind.
Yeah, you just multiply down. We're gonna do harder problems. Let me show you a harder one right now. All right. Now, that is not a 15 and that's not a 10. So you can't divide by 5 and divide by 5 because 15 holds a bunch of numbers and 10 holds a bunch of numbers. So let me show you what we can do. We have to take 15 all the way down to 1, 14, 13, 12, 11. But watch what I'm going to do. I'm going to stop at 10 factorial because I notice the bottom is 10 factorial and we can cancel parts of a product, can't we? Yes or no?
Yes.
So 10 factorial is a bunch of numbers, and this 10 factorial is a bunch of numbers, so can't we just cancel it out? So isn't our answer just going to be 15 times 14 times 13 times 12 times 11? So tell me what the answer is. What's 15 times 14 times 13 times 12 times 11? Still waiting. 15 times 14 times 13 times 12 times 11 on the calculator.
It's going to be 300,060.
360,000.
Yeah,
360,000.
360.
Right.
Yeah.
All right, now I just wrote this over here so that you know not to do this. So you cannot divide the top and the bottom by 5 and get that. That is not right. Do not do that. That is not a 15 and a 10. All right, now here's, they want you to write the first 4 terms. Whose rule is this. It's a sub n is equal to 2 to the n divided by n minus 1 factorial. So that's the rule. And they want us to, it's not recursive or anything. They want us to find the first 4 terms. So we're going to do a sub 1, which is the first term. And we're going to say wherever we see an n, we're going to put a 1. 1 minus 1 factorial. So on the top, it's just 2. And what's 1 minus 1? 0. Now, what did I say 0 factorial is?
One.
So the answer, a sub 1 is going to be 2. And now we go to a sub 2. So that would be 2 to the 2 divided by 2 minus 1 factorial. So in the numerator, we get 4. And in the denominator, we get 1 factorial, which is just 1. So 4 over 1 is 4. I don't know why I'm circling those because we're going to write the terms. Shouldn't be circling them. Remember that when you're done making these computations, you want to write the sequence. So a sub 3, the third term, would be 2 cubed divided by 3 minus 1 factorial. So what's 2 cubed? Hello, 2 times 2 times 2.
8.
Over 3 minus 1 would be 2 factorial. So isn't that 8 over 2 times 1? So isn't that just 4? Yes?
Yes.
All right, and finally, a sub 4 is going to be 2 to the 4th divided by 4 minus 1 factorial. So what's 2 to the 4th?
16.
And on the bottom, you would have 3 factorial, which is 3 times 2 times 1. And let me say this much, you guys. When this gets to be complicated, couldn't you cancel the 2 and the 8 because it's part of a 2 and the 16 because it's part of a product? So we don't want to multiply everything out and then simplify. Can't you simplify 2 and 16 right now? It's part of a product. Hello?
Ms. Birch, wait. So, okay, never mind. I get it. I'm sorry.
Look it, hold on. Let's say you had this. Let's say you had 2 times 3 times 4 times 5 times 6 times 7 times 8. And on the bottom, you had a 10 times 8 times 3 times 2. Do you want to multiply all that out and multiply all that out? Of course you don't. So if it's part of a product, couldn't you cancel the 8s? Couldn't you cancel the 3s? Could you cancel the 2s? And even with the 10, you could cancel a 5 and get a 2, and a 5 would be a 1. And you could cancel a 2 with a 6 would be 3, so your answer is 3. Did you follow that or not? No, your answer is not 3. I have a 7 here. It'd be 20. It'd be 12 times 7. What's 12 times 7? 84. You guys see what I'm doing? 7 times 3 times 4 is left over. Do you see what I'm doing, or do you want me to do it again?
No, I can see it.
The rest of you? Do you want me to show you again?
Sure.
Okay. So let's say on the top you're multiplying and you have like a 1 times a 2 times a 3, 4 times a 5 times a 6 times a 7. And on the bottom, you have like a 9, a 12, and a 14 for some reason. Well, when you have a product like 2xy over 4xy, don't we simplify? I mean, isn't this 1/2? So couldn't you do the same thing with numbers? Like, couldn't you say divide by 7 and get a 2, divide by 6 and get a 2, divide by 3 and get a 3? And then couldn't you cancel those 2's? And cancel the 2 with the 4? So wouldn't your answer be 2 times 5 over 3? So you could simplify that way, right? Yes, no? So what you're seeing me do here is you're seeing me divide by 2, you get a 1, divide by 2, you get an 8. So 8 over 3. Do you understand what I'm doing or not? Because I don't know if you know what I'm doing or not.
Yeah, I get it.
Yeah, same.
All right, now remember that they asked you to find the first 4 terms of the sequence. So you want to make sure that you write out the sequence. So what's the sequence? Well, the first term is 2, the second term is 4, the third term is 4, and the fourth term is 8 cubed. 8 over 3, I mean. Right?
Yes.
All right, so let's do some more factorial problems. Hold on just a second. Let's try some more factorial problems that are a little more complicated. So the bottom line is we don't want to cause ourselves a lot of work. I mean, we just want to do it the simplest way possible. So what if you had 10 factorial, that's a bunch of numbers, over 2 factorial, 8 factorial. Now you cannot cancel that, nor can you multiply 2 and 8. That's not a 2 and an 8. So here, look what I'm going to do. I'm going to take the 10 down to 8. Hold on. I could do this, right? Instead of going 1, 2, 3, 4, 5, I could go down from 10 to 9 to 8 factorial. And that 8 factorial is going to cancel with that 8 factorial. And then 2 factorial would be 2 times 1, right? So I'm taking the factorials down backwards. So 9, 8, 7, 6. I'm going backwards down to 1. Okay? So I'm going backwards down to 1. So those would cancel, and 2 goes into 10 5 times. So wouldn't your answer be 45? Want to do another one?
Yes.
Okay. So let's say you had 15 factorial. And on the bottom, you had 3 factorial and let's say 10 factorial. Well, you could go 15 down to 1, right? So this would be 15 times 14 times 13 times 12 times 11. And then I could stop at 10 factorial because I can cancel it with that guy. And then the 3, you would take it down to 1. And so now you could cancel the 3 and the 15. You could cancel the 2 and the 14. And so your final answer would be 5 times 7 times 13 times 12 times 11, whatever that is. It's a big number. So what would that be? What's 35 times 13 times 12 times 11?
$60,060.
60,000, does it look like that?
Yeah.
Okay. All right, do you guys have any questions about this? You want me to do another one? You guys okay or no?
Yeah, I'm okay.
Okay, you want me to do another one? Hello?
No, I think I'm good.
All right. Can I have one more objective? I actually have two. I'll just finish this. I'll finish this on Wednesday. All right. So what I want you to do is go to your teams, and you're not going to work on anything else. I want you to see if you can do some of these problems. So we're on page 1048. I have not posted this lesson yet because I'm not finished with it, but I do want to see if you can do this, okay? This is chapter 10:1. I want you to see if you can do a couple, like, see if you can do 1 and 3, and see if you can do 13 and 14. Those are the recursive ones, okay? And so try to do 1 and 3, and try to do 13 and 14, okay? And I'll be checking in with you and taking attendance in the Math Wizard teams. Okay, we will not report back, and class is over at 10:45. All right, I'll see you in your teams.